Okay, these are what most of your chain rule type problems are going to look like. Okay, so here our outside function is going to be this negative 1/3 power. So let's write it. It's going to look nasty. I don't think this one simplifies nicely. So y prime is going to be negative 1/3 at the beginning. Then we have x to the second power plus 7x plus 2. Nothing's changed with the inside. And then I take 1 away from that. So that would be negative 4/3. Okay, you cannot distribute this, guys. You cannot do that. Because you have to do the power first before you can multiply it. Don't make that mistake. Then we multiply it times the inside. The derivative of the inside. The derivative of the inside is going to be 2x. And then you have to take the derivative of 7x, which is just 7. So we're multiplying that times that. Notice how I have parentheses around here? So we actually, if we did have to multiply this all out, you would be foiling stuff. Okay, but I would just leave it like that. I mean, it's going to get really nasty there. Alright, it was asked that I identify the f and a g. See, I was wondering if that helped you guys. So the f function for a is going to be, let's see, how would you say it? Okay, you can say this two ways. I think I'll just stick it with the power. So it's going to be x raised to the negative 1/3. And then the inside function, your g function, is going to be x squared plus 7x plus 2. Okay? Okay, so let's start with identifying the f and g for this next one. So for b, your f function... Oh no, that is finished. I mean, yeah, you probably can like spend a lot of time simplifying this, but it's just going to get really, really, really hairy. You don't need to do it. Okay?
If that was on the test, that would be the answer?
Yes. Yeah. Okay, so f is your outside function, and g is your inside function. What's the inside function? That's actually easier to identify, in my opinion. Yeah, cosine of t. Normally, the inside function, I guess, would be the first thing that you do to the variable. Okay? The f function is the second thing you would do to it, and so you would raise it to the base e, so it would be t. Oops, I got to get rid of those x's. This should say t's. Yes. It matters which one is the outside, which one's the inside function. Sometimes it doesn't matter, but those are rare cases. So, like I said, I would think of it like, okay, if I were to actually plug something into this function, what does something to it first? Does the cosine do something to it first, or does the base e do something to it first? The cosine does. Like right here. The inside polynomial right here will do something to x before you're going to do the power, right? So that means the inside part is your inside function. So whatever is going to do something to the variable first, that's going to be your inside function. Okay. And I'm curious to see if that doesn't work in a situation, so let me know. Alright, so if I take the derivative of b, let's see, we got the derivative of the outside, which is just e to the x, or e to the t. Now, the derivative of e to the t is just e to the t, so we're just going to write e to the cosine of t. Then we're going to multiply that by the derivative of the inside, which is cosine t, and that's negative sine t. Okay? So, this could be your answer, or you can write it, I mean, there's different ways to write this. So let's write, let's try doing it like this. Let's just go negative e to the cosine t times sine t. So that's another way to write it. Both of these answers are correct.